Past problem. If the equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0 represents a pair of intersecting lines, then show that the square of the distance of their point of intersection from the horizon is equals to c into a plus b minus f square minus g square by ab minus h square. Also show that the square of this distance is f square plus g square by h square plus b square if the lines are perpendicular. So given question is the equation represents a pair of intersecting lines. So first what we take, the lines represented by this equation are L1x plus M1y plus N1 is equal to 0 and L2x plus M2y plus N2 equals to 0. Those are the lines represented by the given equation. Now show that the square of the distance of their point of intersection from the horizon, that is, for suppose these are the lines, which are the lines represented by the given equation, and this is the point of intersection of the two lines. So first we have to take the point of intersection of the two lines. The question is the square of the distance of the point of intersection from the horizon. So first we take the distance between the horizon and point of intersection and square of the distance, that is OP square. Now we want to show that the square of the distance of the point of intersection from the horizon, the square of the distance of the point of intersection from the horizon, here the distance is equals to OP, square of the distance is equals to OP square. Now we want to show that the square of the distance is equal to c into a plus b minus f square minus g square by ab minus h square, that is we want to show that OP square is equal to this value, and also show that the square of this distance is equals to this value if the lines are perpendicular. That is, what is the condition for perpendicular lines? A plus b is equal to 0. If the value a plus b is equal to 0, then the lines are perpendicular. So we substitute that a plus b is equals to 0 condition in the first answer, then we will get the second answer. That is, we can deduce the second answer from the first answer by substituting that a plus b is equal to 0 in the first answer. So here the given question is we want to show that OP square is equal to this value, and after that we will take that a plus b is equal to 0 in the first answer, then we will get the second answer. So this is the procedure. So first what we want, first we take that the lines represented by this equation and finding the point of intersection and doing that OP square value. So first I take the given equation here. Given equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. Now it represents the lines. The first line is L1x plus M1y plus N1 is equal to 0, and the second line is L2x plus M2y plus N2 equal to 0. Therefore given pair of straight line is nothing but the product of the two lines. Therefore ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to product of the two lines, that is L1x plus M1y plus N1 into L2x plus M2y plus N2. Therefore pair of straight line is equals to product of the two lines. Now we are taking the product of the lines here, L1x into these three values. Now what is first value? L1 L2 x square, and what is second value? L1 M2 xy, and third value L1 N2 x. Next M1y into these three values, that is L2 M1 xy, next M1 M2 y square and M1 N2 y, and last values N1 into these three values, L2 N1 x plus M2 N1 y plus N1 N2. So these are the product values. Now this is equals to, first we are writing the x square term, that is L1 L2 x square. Next writing xy terms by taking xy common, means we are writing the terms in order, L1 M2 plus L2 M1 into xy. Next we are writing y square term, M1 M2 y square, x square term, x square term, y square term. Now we are taking the x terms. What are the x terms here? L1 N2 x, L2 N1 x, that is taking x common here. Then we get L1 N2 plus L2 N1. Now writing the y terms. This is y term, this is y term. Taking y common, M1 N2 plus M2 N1 plus last constant value N1 N2. Now we compare the values in both of these equations. Therefore the first value, by comparing the similar terms here, we get first value x square quotient, that is A is equals to L1 L2. Next xy quotient 2h, xy quotient L1 M2 plus L2 M1, that is 2h is equals to L1 M2 plus L2 M1. Next y square quotient B is equals to M1 M2. Next value x quotient 2g is equals to L1 N2 plus L2 N1. Next value y quotient 2f is equals to M1 N2 plus M2 N1. And last value constant c is equals to N1 N2. Now what is the given question? We have to take the point of intersection and distance of that point of intersection from the origin and square of that distance. We have to find that value. So first to take the point of intersection of the two lines. Point of intersection of lines is equals to, what are the lines here? The first line is L1x plus M1y plus N1 is equal to 0. And the second line is L2x plus M2y plus N2 equal to 0. Now how to take the point of intersection? First we take the middle values. Point of intersection cross product method. First we take the middle values, next last values, next first values, again middle values. Middle, last, first, again middle. And here we put x, y, 1. X by M1 N2 minus M2 N1 is equals to y by L2 N1 minus L1 N2 is equals to 1 by L1 M2 minus L2 M1. X by M1 N2 minus M2 N1 is equals to 1 by L1 M2 minus L2 M1 and y by L2 N1 minus L1 N2 is equals to 1 by L1 M2 minus L2 M1. Therefore the value of x is equals to M1 N2 minus M2 N1 by L1 M2 minus L2 M1, and the value of y is equals to L2 N1 minus L1 N2 by L1 M2 minus L2 M1. Therefore this is the point of intersection. Therefore point of intersection is P is equals to, we take the point of intersection is equals to P here, M1 N2 minus M2 N1 by L1 M2 minus L1 L2 M1, L1 M2 minus L2 M1, comma L2 N1 minus L1 N2 by L1 M2 minus L2 M1. Now this is the point of intersection. Now what is origin? Origin O is equals to 0, 0. Now what we want? Square of the distance. We want the value of OP square. Distance between these two values is equals to OP square, that is square root of. So what is the distance value? M1 N2 minus M2 N1 by L1 M2 minus L2 M1 minus 0 whole square, x2 minus x1 whole square plus y2 minus y1 whole square, that is L2 N1 minus L2 N1 by L1 M2 minus L2 M1 minus 0 whole square. This is the distance, but here we take that OP square, distance whole square. Now here square and root gets cancelled, and this is equals to, what is the numerator value of the first fraction? M1 N2 minus M2 N1 whole square by, this is L1 M2 minus L2 M1 whole square. Separating the squares. Here also this is L2 N1 minus L1 N2 whole square by L1 M2 minus L2 M1 whole square. Now the both of the fractions have the same denominator, now taking LCM. So this is equals to L1 M2 minus L2 M1 is whole square here. Now writing the numerator values, M1 N2 minus M2 N1 whole square plus L2 N1 minus L1 N2 whole square. Now here I apply one formula, that is a minus b whole square is equals to a plus b whole square minus 4ab. I take that formula here. I apply this formula to all the three terms. Now what is first term? I apply this formula to the first term, that is m1 n2 plus m2 n1 whole square minus 4 m1 m2 n1 n2 plus, from applying the same formula to the second term, L1 N2 plus L2 N1 whole square minus 4 L1 L2 N1 N2 whole by. This is also L1 M2 plus L2 M1 whole square minus 4 L1 L2 M1 M2. And this is equals to, and in the comparison already we have some values. M1 N2 plus M2 N1. What is that value? That value is equals to 2f. 2f whole square minus 4 m1 m2 n1 n2. m1 m2 is equals to b, n1 n2 is equal to c. For bc, this is l1 n2 plus l2 n1. But what is that value? 2g. So this is 2g whole square minus 4 into l1 l2 n1 n2. What is that value? ac whole by L1 M2 plus L2 M1. What is that value? 2H. 2H whole square minus 4 into L1 L2 M1 M2 AB. Means we substitute the values here, and this is equals to 2F whole square, 4F square minus 4BC plus 4G square minus 4AC by 4H square minus 4AB. Now taking 4 common here, 4 into f square minus bc plus g square minus ac by 4 into h square minus ab. Therefore answer is equals to, now taking minus to get the answer, just taking minus common from the expression, that is minus of ac plus bc minus f square minus g square by minus of ab minus h square. Therefore distance value is equals to c into a plus b minus f square minus g square by ap minus h square. Now this is the distance value op square. Therefore square of the distance op square is equals to, the answer is c into a plus b minus f square minus g square by ab minus h square. And what is the special case? If the lines are perpendicular, then what is the distance value? So what is the condition for perpendicular lines? If the lines are perpendicular, then a plus b is equal to 0. A plus b is equals to 0 means the value of a is equals to minus b. Now we substitute these two values in the op square distance value. That is op square is equals to c into 0, since a plus b equal to 0, minus f square minus g square by a value equals to minus b into b minus h square. That is minus f square minus g square by minus b square minus h square. Taking minus common, minus of f square plus g square by minus of b square plus h square. So this is equals to f square plus g square by b square plus h square, which is the distance if the lines are perpendicular. That's all. This is the answer.